Welcome to The Explainer. Today, we're diving into something called computational thinking. It's a powerful mental model that, well, it teaches you how to solve problems like a computer. And trust me, it's already a total game changer in some huge industries. So let's just start with a big question, right? What if you could actually borrow the logic, the pure efficiency of a computer to tackle your toughest challenges? And I'm not just talking about tech stuff. I mean, at your job or even just in your day-to-day life. Now, I know what you might be thinking, but this is not about learning to code. Not at all. It's about learning to think in a totally new way. It's a framework, really, for anyone who's looking for a smarter, more structured approach to problem solving. Okay, so let's get right into it. What exactly is this way of thinking? And, how does it actually work in the real world? So at its heart, computational thinking is all about this. You take a big, messy, totally intimidating problem, and you reformulate it. You break it down until it becomes something you can actually wrap your head around, something you can solve, one piece at a time. And you know what makes this so incredibly useful? It's that it's grounded in reality. It's not about searching for some perfect ivory tower solution. Nope. It embraces the real world. Constraints like time, resources, and finding a solution that's good enough to get the job done efficiently. All right, the whole framework really boils down to 4 key steps, and they're simple, but they are incredibly powerful. This process it's so logical, you're gonna love it. Okay, first step, decomposition. That's just breaking a huge problem down into smaller bite-sized parts. Step 2 is pattern recognition. You look at all those little parts and you start finding similarities or trends. Then, for step 3, you create algorithms, which is just a fancy way of saying you develop simple, step-by-step instructions to solve each of those little problems. And finally, number 4, abstraction. This is where you zoom out. You take what you've learned and generalize it into bigger principles. It's just a fantastic, repeatable process for getting to clarity. Okay, to really see this thing in action, let's check out a great analogy. It's a tale of 2 baseball coaches. So the challenge for both of these coaches is exactly the same. Select the best possible team from a huge pool of players. Simple goal, right? But their methods for getting there are worlds apart. All right, check out this contrast. On one hand, you have the traditional coach. He's going to individually test every single player. It's slow, it's resource intensive, and it's based on a simple pass-fail system. But then you have the computational coach. He skips all that universal testing. Instead, he analyzes data, things like past performance, training, physical attributes, and he builds a model to predict success. The result? He gets pretty much the same outcome, but way faster and so much more efficiently. This whole idea is based on the insights of a guy named Keith Schaub, who's a VP at a company called Advantest. He points out that the real job in the future isn't going to be testing. It's going to be devising smarter ways of predicting failure. And he should know, because he saw this thinking completely transform his own industry. Okay, so let's move from that baseball analogy to see how this is sparking a real-world revolution in a super high-tech field. Because this isn't just a story. That method, used by the computational coach, that is exactly how the job of testing semiconductor chips is changing right now. So what we're seeing is a fundamental shift in what the job of a test engineer even is. The old way was all about manual, individual chip testing. The new way, it's about building AI-driven prediction models. The focus used to be on a simple pass or fail. Now it's about predicting failure patterns. And the skills you need? It's not just about operating technical equipment anymore. Now it's all about data analysis and refining those models. The job itself is being transformed. Yeah, the whole shift is from finding defects to predicting them. It's a huge change in mindset, really. It's moving from being reactive to being proactive. All right, so this is all great, but how can you actually put this to practice? How can you use this to solve your own real-world challenges? Well, you can use computational thinking to find out, where do your best employees really come from? What's the actual reason your customers aren't renewing? Why do breakdowns keep happening on your production line? Which of your marketing strategies are actually truly working? This is about honing your judgment with data. Look, at the end of the day, this is your tool. It's a way to take on those really tough, intractable problems with a clear, structured approach. It gives you a repeatable process to find answers that are buried in all the data that's already around you. And that really leaves us with one final thought, one question for you. Now that you've got this framework, what's one of those unsolvable problems in your life that you can now start to rethink?